So here we got the directional cosine of the vector v as equal to minus 0.385 I cap plus 0.923 j cap. So this is how we find out the directional cosine of a given vector. Next problem, a force F of magnitude 600 Newton acts at the origin of a coordinate system. Knowing that Fx equal to 200 Newton, theta z equal to 30 degree, determine the component Fy. So let us solve this problem. So here given data, magnitude is given, say that is F 600 Newton, and the x component of the force is given, Fx equal to 200 Newton, theta z is given, that is equal to 30 degree. So what we have to find out here is the Fy, y component of the force F. So here as theta z is given, F known, we can find out Fz. Fz is equal to F cos theta z. So substituting the values here, what we get here is so Fz is equal to 519.62 Newton. Once we know Fx, now Fx is given, Fz is known to us, we know F, we can find out now F using the formula. So that is F square or F square is equal to Fx square plus Fy square plus Fz square. So F is equal to 600 square, Fx given 200 square, Fy we have to find out, and Fz 519.62 square. From here what we get, this Fy value is equal to, so we get this after substituting the values, we get this Fy equal to 223.6 Newton. Next problem, if a force of magnitude 250 Newton acts along a line AB where A and B coordinates are given, then what is the angle that force makes with the z axis? Then what is the force makes with the z axis angle, we have to find out. So F is given 250 Newton, and this F is passing through 2 points from this A to B. So point A is given 40, 0, minus 30, and B 0, 80, and 0. So we have to find the angle made by this force F with the z axis, means we have to find out theta z, and we can find out this cos theta z using this, because A and B are given, A B lies on this force line. So cos theta z is equal to z2 minus z1 by L. So here it is A to B, so this is x1 y1 z1, A becomes x1 y1 z1, and A to B, so it will become x2 y2 and z2. So here L value is equal to under root x2 minus x1 whole square, so that is 40 square, y2 minus y1 whole square, that is 80 square, and 0 minus 30, that is 30 square, and this value is equal to, so we got this L is equal to 94.34. Now z cos theta z, that is z2 minus z1, 0 minus of minus 30 by 94.34. So this value 30 divided by 94.34 is equal to around, this is 0.318, and from here theta z is equal to inverse cos inverse of this, so shift cos inverse, so this value is equal to 0.318. This angle is around 71.46 degree. So this is the angle that is required. So we got now this angle theta z is equal to 71.46 degrees. So after solving this problem, that is finding the angle made by the force with the z axis. So here we got theta z is equal to 71.46 degrees. Now let us move on to briefly review about the vectors. So here consider three vectors p bar, q bar, s bar, and their components are like p bar equal to px I cap and plus py j cap, pz k cap. Similarly q bar qx I cap, qy j cap, qz k cap. S bar equal to sx I cap, sy j cap, sz k cap, such that the magnitude is equal to p is equal to under root px square plus py square plus pz square. Similarly q is equal to under root qx square plus qy square plus qz square, and s also. And if you consider the cross product of this vector p and q, p bar cross q bar is a vector perpendicular to p and q and also perpendicular to the plane containing p and q, and this p bar plus q bar is equal to pq sin theta and det of ijk px py pz qx qy qz. And coming to this p bar plus q bar, it will represent area of a parallelogram with p and q as the two adjacent sides of the parallelogram. And now if I consider the dot product, p dot q is equal to pq cos theta, and further we can write that is px qx if you want to write to this value. So if, because we know the vector, so it is px qx plus py qy plus pz qz. And also if you take the triple product, that is the s bar dot p bar cross q bar, that is equal to det of sx xy sz px py pz qx qy qz, and that will represent volume of a parallelepiped. So now let us move on to discuss about this, briefly discuss about this projection of a vector onto a given axis. So here consider this is x axis, y axis, z axis, and there is a vector p starting from the origin and going in this direction, vector p, and OL is the given axis. If you draw perpendicular from the two ends of this vector, that is from this end and from this end, two perpendiculars, then that line that intersects this given axis is equal to the projection of that vector onto the given axis. So here in this case, if we project this draw these normals from this vector p onto this axis, normals, one is this is going to fall at point A, and other one from here if you draw, it is going to fall at point O only. So OA represents the projection of this vector P onto this given axis. So if you consider this triangle, this is a right angle triangle. So from this right angle triangle OA, that is nothing but projection of this vector P onto the given axis OL. So we write as OA is equal to P suffix OL. That is projection of this vector P onto the given axis OL, that is equal to P cos theta. OA is equal to P cos theta. This is P. This value, this magnitude is P and theta. So cos theta is equal to OA by P. So OA is equal to P cos theta. And say next here, in this case if you consider, let us say a vector Q is acting along this given axis OL. Then the projection of this vector P onto the given axis OL will become OA is equal to P cos theta, that is equal to P OL, and we can write this P cos theta as P bar dot Q bar by Q, because P bar dot Q bar is equal to PQ cos theta. Q will get cancelled, you will get P cos theta. Or so further if you write this formula, you will get Px Qx plus Py Qy plus Pz Qz by Q. And if Q is a unit vector acting along this given axis OL, that is say lambda, so lambda is equal to cos, that is the directional cosine vector of this vector Q, that is lambda. So cos theta x I cap plus cos theta y j cap plus cos theta z k cap. Then POL is equal to P cos theta, that is equal to P bar dot Q bar. Now Q bar is equal to lambda bar, so it will become now Px cos theta x plus Py cos theta y plus Pz cos theta z, where cos theta x, cos theta y and this cos theta z are the direction cosines of this axis OL with respect to the x, y and z axis. And also these angles theta x, theta y, theta z are the angles made by the axis OL with respect to this x, y and z axis. So this is briefly regarding the vectors which we require when we discuss more about this moments and moment of a force about a point. So next we will discuss regarding this. So far we have covered force systems which are coplanar, concurrent and concurrent in space. So next we will discuss about the equilibrium of a particle, maybe in plane or it may be in space. Thank you.